Yo, what's up, everybody? Welcome back. Today we're working on a barcode scanner. The idea here is, I like data, right? Data's fun. I want to keep track of the stuff that I have in my fridge and have like my meal tracking application, like know how much of everything I have and figure out like what meals can you make today, right? When I'm like, oh, I don't know what do I want to eat. I don't know. If it's just like here's a list of the things that you've made before, and like here's the stuff that you can make that match that list, that'd be pretty sick. And so I'm thinking, as I load the fridge from when I get home from the grocery store, I just whip out the phone and I go like beep 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 as I put stuff in. And part of that is I want to make sure that that process is like quick and easy, right? So I think somewhere I took a video of me just trying to like look at a barcode. And you'll notice a few things here. Oopsies, I didn't want to do that. Hold on, I gotta fix this guy real quick. Okay. Looking at this, you'll notice a lot of frames are blurry, right? There are shadows, and specific, like, oh my god, why is that growing? What the fuck just happened? Is it full screening every time the video resets? That's so fucking annoying. But also, like the image itself doesn't take up the whole field of view, and getting it to take up the whole field of view is actually kind of fucking hard because like you can't get close enough to the barcode to have it fill up the field of view and be in focus, right? So we need something here that will like extract the barcode. Now, another thing that's going on here is like, why are we doing this now, right? We don't even have like a fully functional barcode scanner. The reason I want to do this now is because I was looking at what we did yesterday. So our current approach for filtering a barcode is we kind of do some sort of like edge detection via some like canny-esque edge detector, a little like modified for whatever the fuck we're doing. We have some like areas with holes in here, right? And so if we're trying to use these edges as reliable signal, as like how to go between things, well, then we like say, okay, we'll like kind of bridge some of those gaps if we can. And then the idea was originally that we can turn this into like some run length encoded data row per row, and we can kind of like parse the barcode on every row, and you have some form of consensus of like the real number, right? I'm realizing now, fucking stupid. Fucking stupid. What we should do is, as part of the edge data calculation, we've actually got like a kind of like gradient. So like it's kind of more like a heat map of where there might be edges. So you're gonna have some sort of like, low intensity, high intensity, low intensity, low, high, low, high, right? I mean, what I really think we should do is if we can reliably get vertical bars, then we can just use that information to collapse all of that gradient data into one row and then use that to like pre-process this stuff. We should then be able to leverage all of this information that we have like a big bar of black, like we can use like vertical color averaging as well as horizontal color averaging to figure out like what color this thing is, which is kind of nice. I think it's like a better approach, but it relies on the idea that we can reliably get up and down signal, which we could do by placing the thing in the camera right way up, but I don't want to have to do that because I want it to go quick, right? Guys, don't say that you want to drink some tuna Coke soup. That's gross. I have more than tuna and Coke in my fridge, okay? I have vegetables. I bought some mushrooms yesterday. They're good. we're not drinking Coke tuna soup. That's disgusting. So I think that what I want to do is I want to try extracting a barcode from a bigger tuna mushroom Coke soup. No. We're not putting the Coke in the soup. God damn it. Okay, so yeah, my thought is that I want to be able to extract the barcode. And so what I'm thinking is we can do some sort of like gradient calculation, right? Basically find the direction and like intensity of how much there are edges. And presumably a barcode is like a thing that has a bunch of gradients that are like relatively high intensity and lining up, right? So on a barcode, we should always have like a line, boom, of like, we have signal going this way. And so I think that if we can kind of like process the image at sets like relatively low resolution, find an area of high frequency that all lines up, we should be able to like pull a barcode on that. Maybe. I guess we'll see. But that's kind of the idea that I wanted to try. Maybe it'll go nowhere. But maybe it won't. So that's the plan. that is the plan. So I guess let's just start by ripping a Sobel operator over this thing. So Sobel. We've kind of looked at this the other day. Um, what is this thing called? Sobel operator. So the idea here is you have these boxes, image kernels, boxes. They're simple. The idea is that you are like in a picture, you are looking at some pixel in the picture, and you want to look at like the surrounding pixels, and you want to like weight them by some amount, right? So I'm an app web developer. Any project ideas to generate income? Dude, that's something you gotta figure out. If like I don't think you can just go around and ask people, how do you think I should make money? Like, because if they're like, I have an easy way to make money, they would just do it, right? That's funny. Yeah, I don't know, man. So like what they're doing here is they're saying pixels on the left of me, one above, one below, and directly to the left. Let's like turn those negative, and the ones on the right, let's turn those positive, right? And the idea here is that if the image is like perfectly single color, these negatives and positives will like balance out. But if there's like a big difference, then the magnitude of this thing will be like kind of high, right? And so they do that both like horizontally and vertically, and then you get like both horizontal and vertical gradients, and you can turn those into diagonal gradients by like merging the two. So we should be able to just like quickly rip that shit over the whole image and just like take a look and see how it looks, you know? So can we do, do we have horizontal Sobel? We have this out here. Let's just take this out of this function, and can we just like rip it on something? So can we just do like, take my input image, and can we say like, Sobel out is image, apply kernel to image. We're looking for U8 output probably, so that we can like just render that out. We need an allocator to allocate the new image. What else is in here? Kernel, so we have the horizontal gradient kernel hype. And we have to like do a thing to that kernel when the numbers come out to convert it to something else. So can we just say Sobel, I don't know, Sobel post-op. I don't give a fuck right now. And I think it's like, what is the post-op API? It's a 2 pixel. So he's gonna take in a kernel. So he's gonna be like, I have, what is the type of this guy? I32, 3x3. He's gonna take in this thing, and he's gonna output a U8. And it's gonna be like, I don't know, in some absolute value. And then the maximum value is gonna be like 255 by times 4. So divide by 4. Something like this. We might want to like, maybe we want to make this look bigger later, but it's fine for now. What is he pissed about here? I didn't close this bracket. Okay. So can we just rate this shit out? Right? U8 ppm, Sobel out, and we'll say Sobel ppm. Let's just take a little peek skis at what this thing does. Try. I don't really run this on a GB right now. Need to write try here, or else he gets mad. Okay. XG open, Sobel. Okay, so this is good news, right? What we are seeing here is that there is, using just like the horizontal one, there's a lot of data here. Now, I would like to maybe like downscale this stuff. Either downscale like the source image or the destination image, right? We don't need this much resolution here. So the source kind of makes more sense to me. Now, I'd worry that resizing the source image down too much could kind of remove the edginess. That's like a thing that could happen. So it might make sense to like kind of blur this guy and then do some sort of like walk on him. But yeah, let's try just like taking the source image, making it really small, and then seeing what that looks like. Let's see, because maybe if you have like your pixel sampling thing, kind of act in a certain way, like instead of averaging, it's just like picking one or something. Maybe it's okay. It really depends on like the filtering mechanism, probably. So like if I do this, and actually I want to rotate this a little bit first, because I think that that will have an effect on how this like kind of gets downsampled. So if we do this, can we actually work off this? That kind of looks nicer to me. I would like to keep the original resolution. Can I like snap a pixel or frame out of this? Can I like VLC save image? Is that a thing I can do? Is that a thing I could do easily? See this tutorial. Okay, create a folder. Okay, shut up, shut up, shut up. Scene video filter, scene filter. Media. Tools. Jesus Christ. Clicks it. I don't want. Okay. We'll just use the original for now. I don't want to deal with this shit. Let's just, maybe. Yeah, it's fine. It's fine. Image. Scale. Like 512. Like, we could go even smaller than this, right? Yeah, you could go, like, even lower if you really wanted to. Yeah. Right, like, that signal is still very present. But it does seem like we're kind of losing maybe the directionality a little bit. But maybe that's okay. How are you looking up what each barcode pertains to? Are they universal? I assume they're universal. It's called a universal product code, so I would hope so. But I was just gonna build a mapping in my thing. Hopefully I don't have collisions in the stuff in my fridge. That would suck. So let's save this out somewhere. And eventually I will have to go take a better picture, but I think this is good enough to test with initially. I actually want to export, huh? So can we call this like a rotated low res? Okay. God damn, that feels good when it's like instant. Yeah, so I think this is pretty good, right? We're still getting like a good collection of edge data in here. And even this, we might want to blur the edge data a little bit. I'd be very surprised if the two brands of tuna use the same barcode. Yeah. Okay, I just want to be clear. I have stuff in my fridge. Okay? So if we were to like, I feel like blurring this makes sense, but maybe we don't have to. Because like, what are we going to do here? We're looking for like an area of high density of lineup, right? So I think the next thing to do is to apply, this is like horizontal. And let's do a vertical gradient as well. Or should we do them both at once? I think we can do them both at once. Can we do like did we've done this already? I think we lost it though, which is fine. It's easy to come back. So let's do apply Sobel, like make gradient, image gradient, something like this. Which is gonna make this thing, which we handily already have. We have the input, which is an image of U8s. Why not just scan the receipt? Because those aren't unique codes. I want like unique codes that map to groceries, and barcodes already have those on them. Also, I don't get my receipts. Okay, so this guy is like we can make an iterator over the whole image. While we iterate by row, while we iterate by column, we are going to apply the horizontal gradient kernel. So this is input, apply kernel at location. Horizontal gradient kernel. And at x, y, huge. Vertical is with the vertical gradient kernel. And we're going to have to combine these somehow. But we'll figure that out in a second. So this is just the same thing rotated this way. 1, 2, 1, and then this is 0, 0, 0. Okay. Okay. So we have the horizontal and vertical, and we can calculate like an angle out of this. So what was our gradient storage? Direction, magnitude, and confidence. I think we don't need this, but we can just leave it for now. Okay. So this thing is we sum this thing, I guess. And then can we do h float is float from int horizontal gradient. VF is vertical. And I actually want to normalize these 0 to 1, I think, is what we did last time. So we do like this divide equals 255 times 4, which is the maximum value on both of these. Okay. Normalize 0 to 1. Okay. Maybe like this. Okay, and then so direction is a10-2 is how we represent this before. Okay. Should be straightforward. And then can we just say like IT pixel or out at, you know, this position is equal to something. Angle is angle, and magnitude is square root of horizontal squared plus vertical squared. Little Pythagoras. If we'll do it, you know, if we're allowed. Okay, so let's make an output thing, which means that we need an allocator here. Out is image gradient initialize with the allocator, and we want to match the input width and height. Cool. And then can we just make the image gradient? Okay. This thing can fail, so we need to write this, because this can fail. Okay. It's not angle. What is it? It's magnitude and direction. And then I think that we have like already a function to write this shit out. Write ppm gradient. And we want to write this on top of something else. Fine. But I think this won't be a problem. So I think that we're not actually going to use that. Hello? F5? There we go. Okay, so this is kind of exactly what I was hoping to see, right? So looking like in this area, we're seeing like a lot of like, you know, arbitrary color, right? But here we're seeing like a pretty consistent orange, which is representing like, you know, top right to bottom left, like top left to bottom right. Ideally, we would be showing different directions, like different colors for the different diagonals, because these are just weighted by x and y like magnitude. So I would like to show that. I would like to show that somehow, which we didn't figure out the other day. So can we do Uh, I mean, I guess you can color it according to the angle, right? Angle to RGB. Right? That's it. This is like a thing we can do. Uh, yeah, he's doing like an HSV shit. Oh, but that's not what he's doing. I don't want to do this again. We've actually done this before. We went through like a whole thing where like HSV is kind of like on like a 3D cube bullshit. I don't want to do this. Can we just ask the fucking idiot? I think this is not the problem I'm trying to solve right now. Given an angle, can you give me a full saturation lightness, HSV, like RGB value, converted from HSV, where angle is adjusting H, in C. We'll say in C, but whatever. I don't want HSV to RGB. You fucking idiot. Okay, whatever. He's just like, I've seen HSV to RGB on the internet before, so I'll copy paste that. Fuck you. Fuck you. But whatever. I mean, I really do not care right now. H, F32, S, F32, V, F32, and then, fine, we'll do it like this. Uh, this is like R temp. I don't really want to think about it. We trust him, which we should never do, by the way. Fuck this guy, he's an idiot. Right? But it is what it is. Ooh, my dog's having a nightmare. uh, R temp equals V GB. This is fine. Uh, this is I32. Okay. Uh, whatever. This all looks maybe fine. Switches in this language are different. Okay. Delete word, find colon, go forwards, arrow, this thing, find break, delete, and do this. Yeah. Okay. R temp is equal to R temp. G temp is G temp. B temp is B temp. This is a lot of work for what I didn't. It's like a really simple. Give me a fucking color. But this is what I get by not using libraries ever. Yep, like this. Okay. Okay. Then we do here, when we do right gradient, we get the color by HSV to RGB from val direction. Is this using, what unit is this? Um, wrong unit, which is fine. Which is fine. Can we also assert that h is greater than 0 and h is, less than equal to stood math pi times 2? Just to make sure. It's fine. And then saturation, I assume they want ones? Yeah. Yeah. This is what they want, huh? This is what they want. They want a little int to float and back. Okay. Then fuck this stuff. This is like color dot r times mag, color dot g times mag, color b times mag. That's what we're looking for. That's what we're looking for here. This is easier if this thing just returns floats, which it does, so we don't have to int from float here. And then we float from int here when we write it out. Okay. Fuck. Int from float. Fine. Fine. He's mad because h is not in that range, so can we do, like... What is it? God damn it. God damn it. I think it's probably in negative pi to pi instead. Yeah, negative pi to pi. If h is less than 0, h plus equals stood math pi times 2. And h in var h is equal to h in. Boom. All right. Cool. So now we should get like some nicer colors. Okay. We want this to be not by 6. We want to like merge colors that are going in opposite directions, right? That's a thing we want to do because this needs to be different than this, sure, but like these are all the same. So this is just the difference between like orange to blue and blue to orange. So we'll just add pi here. While h is less than 0, h plus equals stood math pi. While h is greater than stood math pi, h minus equals stood math pi. Huge. That should make them the same color. Yeah, there we go. Okay, cool. Cool. So can we try, like, just rotating this, different angles? I just want to make sure. So if we do it the other way, we should see the color change from orange to green. Yeah, okay. Cool. So we have, like, some proof that this idea could go somewhere, right? We definitely, like, can find at low res some, like, agreeable guys, and in areas that are not that, we're seeing like non-agreeable guys. Now, do we have any idea about like how like big or shape of this thing? I don't really know. I've seen some barcodes that are really like narrow height, some that are very tall. Maybe we want to look at I don't know yet. Oh, also, I forgot that we should be doing this gradient stuff on a blurry image, I think. That made the canny stuff work a lot better, and I think it'll make this a lot better as well. So can we just do that? We have, can we just do like a, Gaussian blur. So this is a kernel. We had like a 5x5 kernel before. Ah, fuck it. I'll do this later. Oh, we do. I might want to blur the output too, to be honest. So having this around is not that bad. Gaussian, like, image. It's here. It's this guy. Gaussian blur 5x5. So they did 14641. 416, 24, 16, 4 probably, and then 6, 24, 36. Okay. Kernel. Having a scratch allocator here would be nice, but that's a problem for future me. So blurry is a input apply kernel to image. We're looking at a U8 output. We're looking at using our allocator. We're looking for the kernel itself. And we're looking for some sort of, you know, blur post-op here. And was it function 2 pixel? Sum over whatever the fuck it was, 256. Int cast. Okay, all this is looking okay. What's he pissed about here? Yeah, true, huh? This is dot data in here. Okay, and then here we should use blurry instead of input. Okay. Which means this needs to be tried, probably. Okay. Let's just see how that looks. Yeah, okay, that's interesting. Interesting for sure. I wonder if I actually don't want like a 5x5 blur. Like if that's taking too much area. If we're expecting this thing to happen on like a small area, we're actually like doing ourselves a disservice, right? Yeah, so I'm kind of down to not do the blur. That's what I've just learned. Is that like probably by resizing, we've kind of like effectively blurred this thing enough. I feel like I liked this result better. Okay. But I might want to blur the output. So I want to try that now. So we blur. What are we blurring here? Like the magnitudes and directions separately, which we don't really support doing very easily here. If we have mags of like this, which again is a wasteful allocation, but I don't care right now. We can kind of do this, and then we should be able to blur those guys pretty easily. Right, because then we can go like blurry mags, blurry durs, and these are working on F32s, which means that this guy is going to be like F32 everywhere. Cool. And then we return, like, we kind of construct a new image of gradient initialized with alloc input width input calc height. Okay, sure. So then we have to like go like var, you know, out iterator is out iter while out IT next row. We need to like copy the stuff in from the inputs, right? Because we're not really in the correct format. So we just go like out pixel. It was out iterator pixel, sorry. Is equal to magnitude from blurry mags dot pixel here, and direction comes from dirs. Okay, this would be happening on mags, this would be happening on dirs, and this isn't incast anymore, this is just a float. Okay, does that work? Ooh, we don't want to blur directions, huh? Yeah. So we're like taking directions from around us and like merging them together, which is just like fucking up everything, right? So maybe we just want to blur the magnitudes. It's very possible. And maybe we don't even want to do that. Yeah, it's interesting. Okay, I'm not really convinced that this is the play. Not convinced. You know, it might just be nicer to do what we were doing before. Which is, you know, this, but with a lot less work. Okay. Because again, maybe it's like due to us being at such low resolution, this type of optimization doesn't matter. I would like to see some of these black pixels go away, but okay. Okay. Let's say that this is the data that we want to work on. What do we do with it, dude? What do we do? So we probably have some, you know, approximate window size that we're looking for. I kind of want to say that we can kind of work in this space where we expect a barcode to be around this size, right? And what we can do is we can try a few resolutions of image just in case like the barcode's taking up like the full field view or not, right? So we can kind of say like, hey, there's like a small, like a lower bound on what size in the input image we should expect. We'll resize to that size and try those. And then if it's bigger, we can like resize to half width again and then half width again or something like that, right? Or maybe we do it by like mass of thing or something. Let's just start by like doing a clustering thing, and then kind of figure it out from there. So, we've done some clustering algorithm stuff before. Clustering algorithms, Wikipedia, maybe. I need a quick little refresher, but I think that they weren't too bad. Algorithms. So, what did we look at? We looked at dbScan. We looked at hierarchical clustering. I remember liking that one. We looked at k-means. K-means doesn't apply here, but we might as well look it up. I don't. The rest of these aren't like bringing huge. You know, my neurons aren't firing on those. So what the fuck does dbScan do? He has an epsilon and the minimum number of points required to form a dense region. If a point is found to be part of a dense cluster within some distance, its neighborhood is also part of that cluster. So everybody close by. So all points found within the neighborhood are added, as is their own neighborhood if they are also dense, right? So we like kind of like look at each point in here. If we have enough points that are close by, we could start a cluster, and then presumably we kind of like recursively, we kind of like keep going until we don't find any new clusters or something. So we kind of like merge clusters together over and over again, probably. Oh, we just kind of go over each pixel. I see. and then for each point in our neighborhood, which are close by. Okay, that's simple. Okay, hierarchical clustering. I seem to remember it being like, set each point as a cluster, merge clusters based off of proximity, essentially, right? So you just kind of sort by the minimum distance to another point, and you keep merging until you, or to another cluster, I should say, and you keep merging until you run out. Okay. And then k-means was like you put a point somewhere and you kind of like keep nudging it in a direction so that the masses of these like things all even out. And this doesn't work because we don't know how many potential barcodes we're gonna find. I mean, arguably it's one. Um, but you might have multiple areas with high density of aligned edges that are not barcodes, right? Like if you're taking a photo of a barcode in front of a stripy wall or something, you might want to try both. So I'm not really convinced that, I think k-means is not the way. DB scan sounds kind of like what I want, right? We iterate over each point in the image. We look around for points that are close, that are aligned with us, right? We have direction is like an important signal for us. So if they're close by, then we like add it to our cluster. And we just set some thresholds. And then if we have a cluster of a significant size, then we take the bounding box of all of the points in that cluster. Not crazy. Range query sounds like a shit show. Right? This is like, although for us, it's not that bad, right? Because we just, for our range query, is like, just look like in a 5x5 pixel area. Yeah. And then where do these things go? They go into like some sort of cluster list, probably. Okay, it doesn't really matter. We don't really have to do DB scan. We can just do, we can be inspired and do what we want. Okay. So can we say, process image gradient. Cluster image gradient, who is going to take in a, the output of this thing and return probably like cluster points. Clusters. Or something. I don't know, man. Cluster image gradient. Okay. Boots with the fur. This is gradient in. Output is probably like some sort of like list of clusters. I don't know what's in a cluster, but surely it's something. Surely. Hey, what is in here? Like a list of points? Probably, right? That kind of feels right to me. Yeah? Yeah. Yeah, sure. We return a thing that's like a list of points and maybe... Yeah, that's fine. That's fine. And then we can turn this into an image pretty easily by walking each point and just coloring it according to which cluster it's in. Yeah, that's great. That's great. Okay. So for each, I guess we like iterate the image. For maybe you want like an output. Maybe our output actually could just be an image. Yeah, that actually might be easier for now. So if this is like ID, like a cluster ID, you know, I guess we don't even do this. Yeah, I guess that's really all we're doing, right? So we walk the image. I don't know, man, yet. We'll see. We walk the image and we just say like var out is a image I don't know, man. I don't know. That matches the input width and input height. Sure. And all we're doing is like looking. I guess we memset this thing. Okay, so we're just like, yo, if we see another guy with our direction, copy that shit. Sure. Sure. Uh yeah. Okay, so we go like area cluster area iterator is like, you know, input area iterator centered at our position with like a 5x5 area, I guess, right? Little quadruple nested loop. You love to see it. It's beautiful. Tell me that this is not beautiful code. Um, and I guess we're looking at like the pixel in this thing, and we're looking for like if like the directions line up is kind of what we're looking for, right? Now, the directions, we should actually apply that like direction hack that puts it between 0 and pi. We should do that like before visualizing, I think. So here, we should actually be doing like angle equals, what is it, like mod angle stood math by pi. I think that's what I want. We should now change the visualization to assert so that we can like make sure that it's correct. Okay. Okay. This guy needs an alligator. But there's shit. And okay, so now we want to say like I don't know, we're looking at like our pixel. Their gradient is this. And like if our gradient direction minus their gradient dot direction absolute valued, you know, the magnitude of this guy is less than, I don't know, 2. Then we set them to the same cluster, right? Do we assign them both? Yeah, I guess it's like If I guess like we have like their cluster out pixel at their x and their y. Our cluster I guess our cluster, if we are already in a cluster, we don't have to process this pixel, right? Because we're already in one. I guess. If our cluster equals 0 or is not equal to 0, continue. And so we're like trying to assign our cluster to match someone else's, or their cluster to match us. I don't know. We'll just have to see. I think we have to have like a merge list as well. Right? Eventually at the end, like we might end up in a scenario where we've like found two clusters and we need to like put them together somehow. Is that ever true? Yeah, right? Like if you have something like this, right? Uh you might assign this cluster ID 1, this cluster ID 2, and then eventually you'll like hit 1 equals 2, right? And you need to like merge these. I feel like that could happen. Although in our case, we don't really care that much because ours should always be relatively square. Right? We're only looking for squares, so our clusters we shouldn't have that shape. I think that's reasonable. So then we just have to figure out I don't know what yet. So we have to decide if we are only looking at like the center pixel and are we assigning this, or are we assigning the pixels around us too? Because I think that like changes stuff. I think we'll just say we're only assigning ourselves. No, because if we're doing single pass, like this guy might not be in a cluster because he didn't have anyone around him, and then we're finding out now that he's in our cluster. So we do have to assign him. And then that means that we probably do have to process ourselves if we're going to be assigning like to people around us. I think we need to assign both, I think. So like if our cluster is not equal to 0 and their cluster is not equal to 0, we just like don't give a fuck. We like could merge, but we are looking for barcodes which are square. So we shouldn't need to merge disjoint clusters. Yeah. The geometry should prevent any relevant case of this happening. Okay. Else, if their cluster is 0, we say their cluster is equal to, I guess it's both. Their cluster is 0 and our cluster is equal to 0. Then we need to like create a cluster. New cluster ID equals 1, right? So it's like they get the new cluster ID, we get the new cluster ID, and then the new cluster ID goes up by 1. Okay. Hype. Else if their cluster is equal to 0, then their cluster is equal to our cluster. Else if our cluster is equal to 0, our cluster is equal to their cluster. Now, I guess that maybe is right. That might be good enough. I'm not sure. I guess we'll fucking find out. I guess we'll fucking find out. So here, I guess we want to use the clusters here when we write the gradients, right? Maybe write clusters here. We'll figure it out. We'll figure it out. Right clusters. So clusters is a bunch of U sizes. We've got the fucking gradients over here. So color must be I guess the clusters should return like how many clusters there are as well, right? So this is like clusters return is num clusters, as well as the image, which is the image of usize. So then this is like, this returns image is out, and num clusters equals new cluster ID or whatever. Think that makes sense? Okay. Then this guy takes in a clusters like this. And when he writes out to this guy, the color now comes from like we need to like convert it to like an angle between 0 and pi. Cluster angle is float from int of the cluster image pixel at xy. This is using the like old style iterators. Let's upgrade that real quick. While it next call. Okay, so the val is it pixel. Mag is val magnitude, sure. Cluster ID is clusters image pixel at xy. Yup. And the angle is, we convert that to a float. We multiply this by math pi and divide that by the float from int of clusters, num clusters. Yes. Yeah, yep. Okay. I think that does what we want. Then we use the cluster angle here, and that should give us like, you know, colors of different areas, I think. Fuck. I assume, okay, let's check if, is that a bug in the clustering shit? No. Okay. GDB, baby. The fuck is going on? Oopsies. Frame 7. What is H here? 0. Yeah, true. That should be greater than or equal to 0. 0 is valid. So valid. Okay. Okay, so not good. Not good. It does not look like. Actually, can we look at the are we fucking writing this the same thing? Yeah. Clusters. So the question is now is why are these not merging, right? So this looks okay. This does not look okay. We're hoping for some consistent fucking color through here. So it could be that the search range isn't big enough, or it could be that the angles aren't big enough. So let's start by just like really just like cranking that shit, and then we can kind of figure out from there what the problem was, right? So let's make the area just like, you know, 9 by 9 even, and you know, anything within stood math pi. Right? This should color everything exactly the fucking same. Huge. Okay, that's so big for us right now. Okay, so now let's kind of like constrain the angle. We hit it 0.2 before, right? Let's just see what that does. I didn't run it. Right, so the angle seems to be a problem, right? So let's kind of up that threshold a little bit. What's like a reasonable angle, right? We're looking for stuff within like, you know, almost like 30 degrees. 30 over 2 over 3.14159. The fuck? Am I fucking stupid? 30? Oh yeah, wait. I'm a stupid idiot. It's out of 360. 30 over 2 out of 360 times 3.14159 times 2. So like 0.3 is like, that's within 30 degrees. So it could be that the variation in angle is actually quite high. Because, oh, maybe 0.2 was like a little too constrained. Maybe that was why we didn't say 0.3. I wish we could like inspect the values of the angles easily. Like it'd be sick if you could like hover over and be like, that one is this number. But I think that's not super trivial. We could export this thing as an image that has the angles in them and then look at them by like hovering their pixel values in like color paint or something. I mean, it's pretty clear looking at these though. I can't zoom in enough. That's kind of funny. It literally won't let me. But like, there is like a lot of variation in here. Right, which kind of it could explain why we're seeing some like striping here. Can I fucking hide this sidebar? Fuck this shit. Get this shit out of here. Oh, here, this button. Nice. Nice. Okay, right? So like, we're seeing like kind of like stripies like here. And like looking at the pixel colors here, I guess they could be like relatively different in this area, which is maybe interesting. Is it possible that we do need to merge clusters? Are we ever like... Yeah, because we could be like, this guy comes in. I guess like the fact that these colors are different mean that these two adjacent pixels, like 100%, do not think they're the same cluster. Is that true? Maybe not. Let's try merging. I'm not 100% sure that that merge list thing was not required. I'm not 100%. What the fuck is that photo? Don't worry about it. It's supposed to be cluster IDs of a barcode's gradient. We're trying to cluster by gradient direction. And this is that. The clusters are not right. Okay. You can't scan a barcode on that orientation. That's what I'm saying, dude. That's the point. Hope this helps. Thank you. Fix me. This needs to go on some scratch allocator. But for now, I don't give a fuck. So I guess here we're just like our cluster and their cluster is kind of what we append here. And then we go like for each item in the merge list, we go over the whole image. Luckily, the image is small, so this is not as costly as you'd think. While IT next row, while IT next call. If I guess you have to do it like this. If out IT pixel is equal to merge item 1, then we set it to merge item 0. Okay. And then we have to, every time we do this, walk the rest of the merge items, which is funny, and replace we go like for merge list items from start index onwards, other merge item, if other merge item 0 is equal to the thing we replaced, merge item 1. Yep. And I guess we do this for both. Which, shut up. Who gives a fuck that the code looks shit, okay? Okay? It's fine. It's fine. Okay. I think this does what I want. I mean, we should test it, but fuck it. Wow, this is slow as shit, huh? Wow. Super slow. How big is the merge list? What the fuck? 444,000? What? Oh. And our cluster is not equal to their cluster. That's an important piece of this puzzle. $126,000 is still a lot. If you can correctly detect the barcode aligned to the row, why not just rotate the image to 5-degree increments until you find a barcode? Well, that's kind of like what I'm trying to determine here is like, can I assume that the barcode is up and down? Right? That's gonna like kind of change the way that I solve the barcode scanning problem. And that's why I'm doing it this way. Okay. Obviously this is stupid, right? But can we just try? I would just mostly just want to know if it's fucked. So if we start by finding out if it's fucked, then fixing the performance problems, you can kind of handle it that way. Wow, is it really that bad? I have no idea. Okay, we're gonna have to. It's because this is. Let's see, like how far in are we? I did not think this was that bad. I mean, the answer is that we need to fix the fact that the merge list is so large. That's like the real answer. But you don't need to know the barcode orientation. I think you do, depending on how I solve the problem. Because like if I want to assume that the thing is vertical, oh geez, it's gonna take. Oh, that's manageable. We can wait it out. Like, I want to maybe make some assumptions in the image processing about like the verticality of the thing. Oh, the cluster IDs are going to be close together, which is fucking shit up. Fuck. Okay. Hold on. If other merge item is greater than or equal to merge item 1. Oh, this is a pain. It's so hard to visualize. It's so hard to visualize this way. I guess it's just like a bad way of doing solving the problem. We could like stash. We could like stash all of the pixels in a cluster somewhere, and then like merge clusters that way. You know, you could do like a. So like you do a hash map of like cluster ID to pixels, and then like reconstruct the image at the end out of the pixels, which is like a little annoying, but fine. You know? This is really like wasteful for memory, but again, we can solve that problem later. Yeah. Okay, let's try that. So we have like a cluster list, and instead of like assigning to the output or the merge list, their cluster, you need like pixel. Oh, yeah. Wait. No, we still have this here actually as well. So we assign to the output, and then we also have a way to look up all the other things in like that cluster. Yes. So we have this. If their cluster is 0 and our cluster. Okay, if our cluster is not 0 and their cluster is not 0 and they are not the same, then we do like a merge. So their cluster, we look at like the cluster list, get their cluster. Yup. And for their cluster pixels, we say like out at this is equal to our cluster. And then we say like our cluster pixels is our cluster or something. And we say like our cluster pixels dot append slice their cluster pixels. Yeah. And then their cluster pixels, it's like a cluster list remove their cluster or something. Okay. Then we say cluster list here. Put new cluster ID, a new array list. Sure. Sure. So this is like a point 2D initialize the allocator. Again, I'm ignoring everything about deallocating right now. New list here. Something like this, and then we also want like other, what do we fucking call their iterator? Cluster area. Okay. Something like this. If their cluster equals 0, we append them to our cluster. So it's like cluster list get pointer. Ooh, we have to be careful here. These need to be like this. Okay. So we get the pointer of our cluster. Yes. And append their position. Okay. And then in the other way, it's their cluster here and our position. Okay, maybe. So then there should be no merge list here. And we'll see. I don't know, man. I could have written a bug, which would make this a big pain in the ass, but what if we just assume that we don't write bugs? What if we assume that? What if? I never write bugs. Yeah, I'm always saying that shit, dude. Fuck. It's a bug. Our cluster. I guess we need some logs, huh? I would think that we should only be seeing, if we put into the cluster list here, this is the only place where we should need to add. Yeah, I don't really see how this is possible. Our cluster's not 0. Oh, maybe if we didn't merge correctly? That seems possible. So what about when we remove? Yeah, so we remove 3 from the cluster, and then we try to access it again. So, were we not supposed to replace all elements in their cluster with ours? Hum, 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 hum. I mean, we're doing something fucking stupid, and it's gonna be impossible to find because look at this blob of shit. But I feel like it's fine. So we say 0 is invalid. So let's just say we've merging this and this. Right, so we're like, okay, we add 1, we add 2, we add 3, and then we're like, Ah, shit. We gotta merge 3 and 2. Then we find another thing with 3 in it. Which means, well, this just has to be wrong. So if their cluster is equal to 0, we look at our cluster list. Found a pixel. Like, is this happening? This is happening so early, it should be fucking obvious that this is broken. So here, we did find a bunch of things with 3. Right? We did find a bunch of things with 3. Can we double check that out pixel at pixel X and pixel Y is equal to their cluster? Because if that is not happening, then we are really fucking up. Which is not, yeah. So, what the fuck? Interesting. How are we fucking this up so bad? How are we fucking this up? Can I want to print it. I guess it's easier. Uh... Merging 3 and 2. And then we immediately find one in group 3. That's so funny. Can we log the pixel position? Are we like double counting? What the fuck have we managed? How have we managed to fuck this up so bad? 44-0. Yeah, we're just double counting. Which I guess can happen, yeah. That explains a lot. This becomes a hash set. Yeah. That makes sense. That makes sense. That makes sense. No items, yeah, true. Their pixel IT is their cluster pixels key. Um. Hello? Key iter? Cluster list is a thing that maps U sizes to a map of 0.2Ds. What does this thing piss about? Keys maybe? Ah, there we go. While their pixel iterator next. What's it piss about now? What is it then? Zig standard lib. Hash map. Can I not fucking iterate over keys? Auto hash map. Keys. Key iterator. Jesus. All right, fine. If only the autocomplete did this for me. And then we need like our cluster pixels put here. Okay. Please God. Fuck. Okay, so now we're still seeing some pixels that are not theirs. Jesus. So the thing at 42.3. So that means like we must be inserting into the list without writing to the output, right? But I don't really understand how that's possible. Can we not do any merging for a second? Fuck that shit. And can we just assert at the end? Can we just like... I just want to go like 4.0 to like new cluster ID or whatever. I want to look at like the cluster, the pixels. So this is like the pixel list is in the cluster list. Get ID. Can we go like 4? I guess like pixel iterator is from the pixel list. Key iterator, right? While pixel iterator next. Key or pixel. Can we look at out pixel at pixel X, pixel Y, and just like fucking assert that this is this? So without any attempt to merge, is it still fucked? Yes. Right, so... we're actually crashing at like not even seeing the thing in the cluster list. So... the fuck? Dude, am I high? Oh, here, if ID is not equal to 0. Or if ID equals 0, continue. Is that the bug? Yeah, okay. So, good news is, insertion of this thing is working fine, right? It's more that after, like, somehow the merge process is, like, fucking all this up. Which I don't feel like is crazy. I don't feel like it, but it could be. Could be. So we get their cluster pixels from their cluster, our cluster pixels from our cluster. Seems good so far. At this point, everything that's in the map should be okay. We confirmed that at the end, that without merging, everything kind of ends up where it should be. I think that's true. I guess we iterated cluster IDs, not the image, which could be slightly different results, but that's fine. Maybe. Then we say iterate over their cluster pixels. Okay. For each of those pixels, set the output to our cluster ID, and then put that in our cluster pixels. So far, so good as far as I can tell. Adam, yo, what's up? Thanks for the raid. For your guys' context, we are trying to locate a barcode in a larger image. So We are looking at, do I have it open? Do I have it open? Probably this. Yeah, rotate low res, this one. So we have this guy. We're trying to find the barcode in here so that we can look at the larger picture and like unrotate the barcode and do like proper processing on it. The idea was that if we can find where like an area of where all these colors line up, these colors are basically like order of pixels in this thing. Then we could find the barcode, right? A barcode should have like a very consistent big block of stuff. We're trying to build a cluster of these things, and I'm fucking it up somehow. That's what we're debugging when you guys came in. Hope you guys had fun over at Adam's stream. Hope things are going well. I'm just gonna keep going because my brain is melting. I gotta fucking make some progress here. So what we were trying to do is we were trying to like iterate all of the pixels in the image, look around it basically, and say like, hey, is there a gradient close to our gradient? Like, are we going in the same fucking direction? You haven't answered your very important question. Yeah, sorry. Strawberry milk or chocolate milk? I actually don't drink either. I'm actually, I can't, like, milk makes me shit myself. So I actually just drink, like, bean milk. And then I've never really, like, looked into if, they come in strawberry or chocolate. I drink the normal one, dude. Okay. Strawberry bean milk or chocolate bean milk? Yeah, I have no idea. No idea. It's just like not a thing that's like come up. I've never really felt like my milk needed more flavor. That's kind of the thing. It's like it's fine. I'm like in the camp of people who drink like Soylent is like up my alley, right? It's not really about food. You know, taste isn't like a big factor around here. It's about like just getting the fucking shit in your body. Chocolate milk, just extra fluff. Extra fluff. Okay. So, we look at their pixels from their cluster, our pixels from our cluster. Height. We go, hey, can we make sure that the pixels that we think, the pixel at the location that they say they're at is their cluster. And we are like fucking that up. I wonder if there's like some sort of like double merging shit going on. Found pixel, this thing. I mean, we have the number 2 in there. Am I asserting? Oh, this is changing. We're fucking, oh, I'm a dumbass. Their cluster needs to be dereferenced here because we might change it out from underneath them. That's what's happening. That's what's happening. So we've got a pointer to a thing. We're changing it, and then they're going like, what the fuck, bro? Oh, but we need it as a point over there. Yeah, that's a good point. I guess, like, original their cluster is their cluster dot star. Do you ever imagine a computer monitor where instead of pixels, a display of a bean is obviously I've been cutting too much? Yeah, you definitely have been. That's a you are out of it type question. Okay, let's just use that in here and then figure it out from there. For all of you guys coming in from Adam's stream, I swear the code ends up better than you're seeing it now. You're seeing a what we call prototype mode. It's shit, but that's intentional. No point in cleaning it up until it's good, you know? Okay, that made it a lot farther. Now, licking my monitor, that's something I can get behind. Chocolate, for sure. I'd lick the chocolate monitor, not the strawberry one. Um. Okay, yeah. So now this obviously won't work because some of the clusters that we had disappeared. And there we go, baby. Now the question is, I want to, when we do this, when we merge clusters, reduce the number, the cluster ID. Oh, which we can't do. We need to like add it to like a cluster ID list somewhere. Next, cluster IDs. Where the fuck is this thing defined? So we need like a cluster ID cache so that we can reuse them. Okay, we'll do that. Cluster ID cache append original there cluster. And then we can, when we try to get a new cluster ID, Jesus Christ, it's all bad. If new, like, this should be like biggest cluster ID, something that like just forces the name to change. This is like if cluster ID cache pop, we get, you know, this, else biggest cluster ID. And defer biggest cluster ID plus equals 1, and then we break the block with this. Yep. God, it's a disaster, but I think we're good. Okay, now this is biggest cluster ID here. Okay, that's really good news. Unfortunately, it does seem like everything has fucking merged again. Can we try to like reduce the merginess of this thing? Really just drop the fucking angle down here. I mean, that is doing something for sure. I am surprised at like how many clusters are there coming out of this thing now. First of all, we can go back to doing this assertion that like the cluster lists are correct, which they are. Hype. And can we like stood debug print found this many clusters? $46. So there are 46 clusters in here? Oh, I wonder if we're not visualizing the ones that are small, which probably isn't helping. That's probably not helping. Let's show not multiplied by magnitude. And then we can see kind of how it decided to cluster everything. Yeah, let's look at that. Okay. I see. That can't be right, dude. It can't be. It can't be. I guess maybe the angle threshold is like, it should be halved, honestly. Okay, so if we have, say we want like a 30-degree threshold, so this is 30 over 180, this is in radians, but then divide that by 2, so that's kind of, because we're only working with like half range. Maybe that's why. Oh, wait. That's actually looking pretty good. Like, that's promising in some regard, right? Can we multiply by magnitude again? In the visualization? Where the fuck is that? Where the fuck is that? Jesus Christ, there's so much garbage in here, man. Okay. Multiply by the magnitude of the slope. That's like a maybe. I'm concerned that, like, I can't really tell if this is getting the same cluster ID as this. Can we kind of, like, uh, multiply the cluster IDs by a bunch to kind of, like, just add, like, more variance to it? You know what I mean? Like, do something like mod clusters num clusters or something here, just to kind of, like, make it so that things that we added that were close to each other aren't, like, next to each other in number. You know what I mean? S here. Oops. Yeah, there we go. I think there's a good chance that this is the same cluster as this. Which seems really wrong. Like, this direction is, like, so far. So fucking far. So, like, our angles, they have to be wrong, right? Like, am I crazy? I mean, but this is very clearly showing that, like, we know that these are different. So, like, what am I fucking smoking? If our gradient direction minus their gradient direction is less than 0.08, like, that's such a small number, 0.01. Yeah, maybe they're different. I mean, that looks pretty promising, what we're seeing here. But I don't understand why this threshold, like, why this angle threshold has to be so small. I guess it could be that we're not holding, like, a base direction. Yeah, so we're allowing, like, a smooth sweep of angles, probably, to adjust the direction. So we should probably not be looking at an individual pixel's direction, but maybe like an averaged direction or something like that. You know what I mean? Or like a dominant direction. Yeah. Like when we're looking over, like, I guess if we reduce the area that we're searching, that will kind of naturally help this problem. Yeah, for sure. I see. Okay. I see what's happening. I see. There we go. That looks fucking good, dude. That's great. Okay, so we just need to search for, like, in a smaller area. Yeah. That's pretty hype. Okay, so now I think even like this and this are different clusters, right? So can we look only for clusters that have over a certain number of elements? So like for each of these things, I guess like if as we go over all we look over all the clusters, if the cluster size is less than like 100, you know, like rip the list again and set this to 0. I think this is what I want. Just like, you know, nuke any clusters that are too small. That's not what I expected to happen. Oh, because the we need to nuke the gradients as well, maybe. Yeah, this is what I'm really trying to do. I'm trying to filter out and look for. Yeah, there we go. Okay, so 100's too low. 300. Okay, 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 okay. Even more. 800. Let's get crazy. Okay. Does that mean these are the same fucking cluster? I guess that is within like some reasonable angle range, right? So are these, right? Um yeah, like I assume that like increasing this more, it's not like there's like 100 pixels in there, right? Yeah, so we could try reducing the angle threshold a little more. Yeah. I mean, not crazy. Why are we still seeing a red pixel here? We probably also want to not cluster anything where their magnitude is too low, right? So like, and our gradient magnitude is greater than like 0. Over something, and their gradient magnitude is greater than something. I don't really know what like a reasonable magnitude here is. Um, Interesting how that changed something. That had a different effect than I thought it would. Yeah, I'm not quite sure. Our gradient magnitude is less than 0.3. Continue. If their gradient of magnitude is less than 0.3, like who gives a fuck? Yeah, that's really having a different effect than I thought it would. Like, why is everything turning red now? I wonder if it's the cluster. Maybe my like visualization is fucking shit up. Could be. How many clusters do we have? Num clusters. Is it just like my multiply by 10 mod 10 thing to make the colors kind of line up better is fucking us? Num clusters 197. I feel like it shouldn't be. But I guess we could try taking this out. Just to see. I don't think that's it, but I mean, it would be very suspicious if it was. Yeah, I think that these are really all just getting the same cluster, which is like a fucking problem. We, like... I wonder if it's like the search range... No, that doesn't make sense. I was gonna say if like the search range is too large, so we might be looking for like guys that are too far away. Is my visualization not doing what I think? I guess I probably need to, when I'm writing out the clusters, if cluster ID equals 0, write a 0. That's the bug. That's the bug. So we're probably not clustering anything and just visualizing like the original clusters or something like that. I'll bet you that's it. There we go. Okay, that's way more reasonable. Way more reasonable. Okay, okay. Sick. So now we can just go back to, we can like lower this threshold maybe. Like, this threshold is just too large. Oh, tell me that's not fucking sick, man! Tell me that's not awesome. Tell me that's not awesome. Okay, so now all we have to do is, like, find, like, I would love to, draw a line of the, like, direction we expect this to be now. So all we have to do here is I guess we'll just draw it corner to corner or something. I don't really want to write line drawing code right now. I don't want to do that. Can we just write out the angle? So first of all, how many clusters are there? Whoa, whoa, whoa. 1,000? That doesn't sound right. That doesn't sound right at all. Let's look again. Cluster gradients, so... Oh, here we need to remove the clusters that are broken, that's why. Right, so here at the end, we're filtering out clusters that have less than 1,000. So we can just do this. Minus removed clusters. Cluster num or something. Right, and then here we go, like, remove cluster num plus equals 1. Yeah, okay, so now it's 2 clusters. Interesting. So maybe these are 2 clusters here? Could be. Can we, here, get out the magnitude filtering again? Maybe. Maybe. Like, where are these other... I don't believe that those are 2. These are, like, identical color. Oh, it's because 0 is an invalid cluster number. Yeah, so we have 1 cluster, which is hype. That's exactly what I was hoping for. Yeah, it's just the logging there was wrong. Yeah, so we have 1 cluster. Sick. And so I guess in the world where we have 1 cluster, like, we should be able to look at that thing somehow. Can we just go, like... I guess we want to, like, do some sort of, like, statistical analysis of the angles. We probably want to, like, delete any outliers or something, but there probably shouldn't be any outliers because we've already kind of assumed that all of these guys are, like, are similar angle to each other. So it would be good to just be able to be like, I think we just average. So can we be like, if we remove this cluster, can we remove it from the... Can we remove it from... Cluster list, remove. ID. And then we can say... Here, if we do cluster list.count now, we should only have 1. Yep, okay. And then here, we can go cluster list iterator. Cluster iterator next dot key pointer. Oh, I see. Wait, what the fuck? Uh, This is an entry. The entry has the ID and a list of points. So it should just be point IT here. Like this. And then we can loop over all those points and we can average them out. So we can say the total is some floating point number. And the num entry, num elms is a usize. I guess this is just over the like num elms is entry value pointer count. Yep. And then while we iterate over these points, we like look at the gradients from the image that we got in, I guess. Yeah, so we have like input pixel at xy gradient or direction, and we say total plus equals that, float from int. It's already a float actually, and then we say like average dir is this. Total over num elms. Okay. Float from int, I guess. And I guess he has to be like, I'm a floating point 32. And I guess we should fucking new line, I guess, if we're gonna be like this. Okay, so average direction is 2.2. Surprising answer. Yeah, that doesn't look right to me. This should be like, unless the direction is upside down. I think it is. I think it is. Yeah, because we said, we might have flipped y-axis somewhere. We might have. So can we present it with a basically horizontal image to kind of make ourselves feel better about this? Fuck. There's a circle problem in here where we're going to be averaging things that have like an angle of like almost 180 and just above 0. So there's some probably like circular average that we have to do instead. But I don't know how to do that right now. So what we'll do instead is, can we just print out all of their gradients instead of trying to average them? We'll just print every single one. And we'll see if that looks good. Hello? Oh, fuck, I rotated the picture, huh? Which one was it? This one? Fuck. Okay, yeah. So, I think this is maybe right. We're seeing a bunch with 2.2. Can I, like, see what that looks like? K-calc 2.2 times 3, or 2.2 out of 3, god damn it. 2.2 out of 3.14159 times 180, 126. Which, if left is up, or left is, like, if left is 0, that's, like, about right. It's about right. Okay. Well, it's 4:15. I think I need a break. There's obviously some shit that needs to get cleaned up in here. This is an absolute fucking disaster of some code. But the good news is that it seems to create a cluster that's pretty reasonable. I think that, assuming that the like angle problem is fixed, like let's say we did like perfectly vertical. I just want to make sure that like we're not absolutely out to lunch here. Zero clusters found. I wonder what the reason for that is. Just all magnitudes are low. Oh, probably because of like aliasing or something, right? Yeah, that seems kind of likely. So maybe it needs to be a little bigger. Right, we were doing 128 pixels wide. Let's try it a little larger. Ooh, but then all of the like pixel directions and stuff is gonna be different. But let's just see. Let's just see. Okay, there we go. Okay, so that resulted in 2 clusters because like the gap detection was not good enough. But you know, you can tell that there's like something here, right? There's something here. We should be able to like find barcodes based off of this information. We're just gonna have to put a little bit of effort into like making it a little better. But I think the overall approach is promising, right? These guys have found that their direction now is looking a lot more like 3.14/2, which is great, right? I think that these have like a fairly consistent, like the angle, the at angle that it's detecting is like probably good enough that we can have like a relatively up and down barcode at the end of this. So pretty happy with that. Yeah, we'll call it there. Thanks for watching, guys. If you like what you saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. It's 4:20 now. Blaze it. If you're watching live, so anywhere between 4 hours ago and half an hour ago is like approximately when you should expect to see us. We're working on this barcode scanner as part of a larger project that's like an image or a food tracker. And we cover a lot of stuff here. We've done a lot of stuff in the past. If you want to check out the YouTube, there's a lot of other stuff on there. If you want the stream to continue, please consider using your Twitch Prime. I will stop when I run out of money. If you sub on Twitch, sub on Patreon, or as a YouTube member, you get access to whatever VODs I don't post on YouTube. YouTube gets the ones that are like, I can make a title and thumbnail out of this and get clicks. The rest is like, if I'm doing reading or cleanup or just kind of like unstructured work, it's kind of harder to make that a like nice cohesive thing. So the rest of the stuff gets put on whatever platforms, Twitch, Patreon, YouTube, members, and wherever you pay, you get access to the rest of those. So please consider, but obviously no pressure. YouTube, peace out. Twitch, let's find someone to raid.